non-invasive glucose measurement, now with frequency domain precision. Imagine measuring glucose without needles, strips, or pain. Just a tiny ultrasonic sensor on the skin. Here's how it works and why it's finally possible. When ultrasound travels through tissue, its speed and attenuation change with many physiological parameters. But only one of them fluctuates fast enough to leave a strong dynamic signature: glucose. Glucose rises and falls within minutes. Other factors like temperature, hydration, osmolarity, or hematocrit change slowly and can be filtered out. But here is where the innovation becomes truly powerful. We analyze the signal not only in the time domain, but also in the frequency domain. Using Fourier analysis, we decompose the acoustic response into its frequency components. Slow, drifting components correspond to hydration, temperature, osmolarity. High-frequency micromodulations come from mechanical and biochemical effects driven primarily by glucose. Blood pressure and motion artifacts appear as narrow-frequency peaks and can be isolated and removed. In the frequency domain, glucose produces a distinctive spectral fingerprint, allowing us to detect tiny changes that would be lost in traditional time domain analysis. By combining temperature compensation, drift removal, noise filtering, and Fourier domain feature extraction, we isolate a single dominant factor affecting the acoustic signal: glucose. And that leads to a near-linear relationship. Delta C is almost equal to K delta G. This is the foundation of our non-invasive glucose sensor, the prototype you see on my ear throughout the video. Help us complete clinical validation and bring needle-free glucose monitoring to millions of people around the world.